Before we look at our salmon-colored notes, I just want to mention that March is gone, but do you know what March Madness is? So, March Madness is not over. The NCAA championship is coming up very shortly, and so what does this set of numbers have to do with that? It's a bracket. Sorry for those of you that don't like basketball. I like college basketball. And so there's this great, big, huge tournament that starts off with 64 of the best teams in a college basketball teams in the country. And so they play a game, and it's the winner goes on, the loser goes home. So if there's 64 teams, they play a game, half of them are going to go home. So the next time is 32 teams are playing. And then half of them, of course, lose, and they go home. And then we get to the Sweet 16. And then we get to the Elite 8, Final 4, and then the championship till we get to the final winner. Now, what does this have to do with math? Well, of course, there's an equation that goes with this. So, what's happening each time to go, but sorry, we're not allowed to divide in this equation. We can only multiply. So is there something we could multiply by to get to the next level? 0.5 or 1/2. So the equation is to go with this is going to be 64. Where did I get the 64? That's the number you started with. And then, where'd the 1/2 come from? Each time it's 1/2 to get to the next level. And then the x is going to be up here. These are going to be called exponential equations because the x is the exponent. Everything that has an exponent is not an exponential equation. Y equals 64x squared has an exponent. But this one is a quadratic equation. Huh? Well, of course we want Texas Tech to win the tournament. No. I have always liked Gonzaga just because they're always in the tournament. And so, not that I know anything of, anyway. That has nothing to do with our mathematical topic, but this one does. You are familiar with the term going viral. What does it mean? What is it? Do you know what that means? What it means? It usually applies to what? Usually something on social media. We talk about something in social media going viral. Does that mean that it's, what you tell me what it means? Well, so here's something, example of something that goes viral. One video is posted on the internet, and maybe within the first minute, 3 people look at it. Well, that's not very many. But if 3 people look at each one of them, and they repost it, because it doesn't, if you just look at it, it doesn't go viral. It has to be reposted. And so then if each one of those that got posted were looked at by 3 more people, and if each one of those was looked at by 3 more people, well, that's not very much. But it doesn't take very long at all. I skipped some in between. But it really doesn't take very long at all when it's multiplying like this to get to a very huge number very, very fast. So, now, what is this increasing by each time? Adding 3 or multiplying by 3? Because it's not going to go viral unless this multiplies. It's not going to be exponential unless it multiplies. How many did this start with? 1, and then 3 to the x power would be the equation for this type of problem. So these types of problems are called exponential because in the equation, the exponent is the x. Now, there are bunches, lots and lots of real-world situations that do you know why it's called go viral anyway? It comes from the word virus. What does a virus? It spreads very quickly. And so we will be talking about. Now, on my first equation was actually a decay equation because the numbers were going down. The second example was a growth equation because the numbers were going up. Okay, now your salmon-colored video, please. Your salmon-colored notes, please. This is the basic form of an exponential equation. You cannot have something go viral unless it's going to follow this form of the equation. What makes something go viral is this x is in the exponent position. Okay, we need to skip these. So, we have two kinds of viruses, two kinds of exponential equations. Some of them grow and some of them decay. And so, underline this part of your notes. If the b is bigger than bigger than 1, you're going to have a growth equation. It's going to get bigger and bigger and bigger and bigger and bigger. If your b is less than 1, but it has to be positive, it's going to get smaller and smaller and smaller and smaller and smaller until it almost disappears, but never quite disappears. So, here is an equation. Example number 1. The first thing I need to do is look at this number right here. If that number is bigger than 1, it's going to grow. If it's less than 1, it's going to decay. So what are we going to have here? The initial value is the number out in front that does not have an exponent. The b, guess what b stands for? The base number, what number has an exponent? Now, we're always comparing to 100%. 100% is all of something, right? One whole. We're always comparing to 100% or one whole. Is this more than 1? How much more than 1 is it? Now write this down on your paper so you'll know how you come up with this. That is the rate in decimal form. Decimal can be changed to a percent. Percent means part out of 100. So if you multiply this by 100, 0.25 times 100, the percent of increase is 25%. You can, but some people get confused about that. So we're going back to the mathematical reason the decimal gets moved is because you're multiplying by 100. Okay. This number right there, the one that has the exponent, is what you look at for the growth or the decay. So, if it's bigger than 1, it's growth. If it's less than 1, it's a decay. So what do we say here? The initial value is the number out in front that does not have an exponent. Do we have a number out in front that doesn't have an exponent? The initial value is 1. It can't be 0, because if we had a 0 out in front, it would zero out the whole thing. The number that has the exponent is the base. The rate is not 0.25. We're comparing to 100. The rate is 0.25 minus 1. Now, do you know what I just put around that? Absolute value bars, because the rate's never negative. So what's 0.25 minus 1? What would be negative 0.75. But the absolute value of that would be these. I just wrote down right there where I got it. Put it in your calculator. If you put that in your calculator, what do you get? Negative 0.75. No, I didn't. This is the absolute value of negative 0.75. What would be the absolute value of negative 0.75? Why did I do that? Because this always has to be positive. Quickly complete this next example.